Hi everyone. On behalf of all of us here at Washington University in St. Louis and Boise State University, welcome to National Biomechanics Day. Today we're going to talk a little bit about running biomechanics, but first, why are they so important?
I'm Christina Geisler. I am a cross-country and track runner at Boise State, and I'm also studying kinesiology with an emphasis in biomechanics. Biomechanics can lend to discovering why different running gaits are the best. Like you'll hear, oh, their running stride is perfect, and usually those provide the most efficiency, which is going to help you be able to run faster and stay in the race a lot longer.
Hi, my name is Greg Holtzman, and I am a professor here at Washington University Physical Therapy, and I am the director of the running clinic we have as a part of our clinical practice. Running is often related to injury, and it's really important to watch and understand the way a person runs so you can understand what the potential cause of injury could be. When running or walking, the foot is a really important bodily structure that can be used to help absorb those forces. I'll often ask the runner, do they run on a road type of surface that's relatively flat, or are they running on a surface such as a trail in a park that could have some variation in its terrain, such as rocks or roots or dirt or gravel? Sometimes that distinction can be very important because the loads on the lower extremity or on the body can be different in those scenarios.
In order to find out how terrain affects the forces going through the foot, we asked a runner to put an insole into her shoes while running on two different surfaces, concrete and grass. The insole measures how the runner's center of pressure, or where the runner's body weight is, positioned on her foot. It also measures the force going through the runner's foot. Here you can see a diagram of the runner's feet. The green lines show the path of her center of pressure while she was running. We can also see the peak, or maximum force. When running on concrete, the runner had a peak force of 1,260 newtons on her left foot and 1,248 newtons on her right foot. Our runner is now running on grass. And here is the insole data. The runner had a peak force of 1,432 newtons on the left and 1,418 newtons on the right. We can also look at this data graphically. This graph has time in seconds on the x-axis and force in newtons on the y-axis. This trace is the force measured by the left insole during her run. Each of the peaks is when her foot is on the ground, and the valleys are when her leg is swinging through to take the next step. When we add in data from the right insole in orange, you can see how the peaks alternate as she stands on one foot and then the other. If we draw a line at the very peak force observed during this trial, we can see that it corresponds to a force value of 1,260 newtons. If we add in a graph from the trial where the runner was running on grass, we can see a higher peak force value of just over 1,400 newtons. Because this runner experienced higher peak forces when running on grass, it may be beneficial to start returning to running after injury, for example, by training on a flat surface like concrete, and then progressing to uneven surfaces like grass, in order to gradually progress the forces seen by the foot and leg as it recovers.
My favorite thing about biomechanics is that it's more hands-on and it's fun.
My favorite things about biomechanics is being able to have the technology to quantify numbers in order to help athletes.
Another great thing about biomechanics is it's so diverse. You can study animals or running or babies, anything that floats your boat.